Well, let's have a look at the problem that we are going to solve today. It is given that a heater is designed to operate with a power of 1000 watts on a 100-volt line. So this is what that heater is. Its power is given for us. The voltage for which it is designated with that power is given for us. So what can we calculate basing on that? We know the formula that power rated equal to voltage rated square by resistance R. Power rated is 1000 watt. Voltage rated is 100 volts. Voltage rated square by R as per the above formula. So we can calculate the resistance of that heater as, let's take this R into the numerator and 1000 into the denominator. That is 10 ohms. So what's the first thing that we have calculated is this heater is having some 10 ohms. Now let's proceed to the problem. It is given that this is designated to give a power of 1000 watt, but it is connected in the circuit with different combinations like this 10 ohms and this unknown resistance. Thus it is able to give only 62.5 power of watt. It's not giving 1000 watts, but it is giving only 62.5 power of watt. Whatever may be the power that it utilizes and power it is designed for, the resistance of that heater remains constant. Taking that into consideration, I can again write the formula. Here I have derived a formula for power rated. Now I can write a formula for power utilized equal to voltage utilized square by resistance R. But that resistance is constant. Power utilized or power delivered is given to us in the problem as 62.5 watts. So 62.5 is voltage utilized square by resistance of that heater remains constant, that we have already calculated as 10. It implies voltage utilized square is 62.5 into 10, that is 625. That implies voltage utilized is square root of 625, that is equal to 25 volts. So we have calculated one more thing. There is a voltage drop of only 25 volts here across this heater. Let us see what is happening in the circuit. This is a 100-volt source. Current starts from here. Entire current will go through this 10 ohms. Here, these two elements, heater and resistor, are in parallel. So current get divided, but the voltage is same. It means to say when there is a 25 voltage drop across the heater, across this resistance is also 25 volts drop. Now I need to calculate what's the value of this resistance. If I have to calculate the value of that resistance, I need to know, I already know voltage. I can use a Ohm's law, V equal to IR. So if I have to calculate R, I shall know what is the current that is divided as here. So if I have to get the current that is being divided as, let us see how I have to proceed, right? So out of 100 volts, 25 volts is dropped here. Same 25 volts here across the heater because both of them are in parallel. You know, this entire set of heater and resistor is in parallel, but that combination is in series with this 10 ohms. So the entire voltage of this 100 volts gets splits across this and this. So across this combination there is a potential drop of 25 volts. Therefore across this 10 ohms there must be a potential drop of 75 volts. That together this 75 and this 25 together becomes 100 volts. As I am repeatedly telling you, heater and this resistance are in parallel, therefore voltage drop across them is same 25 volts itself. So what I have calculated now, voltage drop across 10 ohms resistance is 75 volts. Now I know the resistance of this, I know the voltage of that, I can apply Ohm's law there. What I can say, as per Ohm's law, voltage across that 10 ohms is equal to current across it multiplied by resistance. We have calculated the voltage already as 75 volts. I don't know, but I know the resistance of that is being given as 10 ohms. It implies the current across that 10 ohms is 75 by 10, that is 7.5 ampere. So here I got the current. Current across this is 7.5 ampere. This is the total current that is released from this positive plate of the battery itself. So I know the total current now. So hope you are following. So there's a lot of concepts and applications. Lots of basics were being studied while you are solving this problem. So from here, a current of 7.5 amperes comes. After reaching this current get distributed here, right? How this 7.5 volts, 7.5 amperes is distributed as I1 and I2 is the thing that I want to know. That means if I know this I1, that is current across heater, is how much is the one question that I need to know first. How can I calculate that? I can use the formula. Power is nothing but equal to VI, right? So power utilized is equal to, I can write a formula, voltage utilized and current that is passed, that is I1. It is already given that the power utilized is nothing but 62.5. Voltage utilized across it, we have already calculated it, 25 volts. What's the current across the heater is the question that I have. So I1 is 62.5 by 25, that is equal to 2.5 amperes. Now I got the value of that I1, 2.5 amperes. So let me choose another color for our convenience. So from here, the total current of, as I have calculated here, 7.5 amperes goes, and that 7.5 goes up to here. After reaching this point, this 7.5 gets splits. How much is passed through this heater? We have already calculated it as 2.5 amperes. So this total current as per the Kirchhoff law must be equal to I1 plus I2. The total current across the 10 ohms is 7.5 ampere. I1 across the heater is 2.5 ampere. That implies I2, that is across unknown resistance of the problem, is 7.5 minus 2.5, that is equal to 5 ampere. So that's almost solved our problem. Now I know the voltage drop across it, 25 volts, because that is in parallel to the heater. Across the heater, voltage drop equal to 25 volts, we have already calculated. Now I know the current across that is nothing but 5 amperes. That implies, again I will use Ohm's law. V equal to IR. Voltage across this resistance is 25 volts. I is I2, I have to calculate. Of course, I have already calculated, that is 5 amperes. So let me substitute that value itself. And resistance R. That implies resistance R is 25 by 5, that is 5 ohms. So while we are solving this problem, just to conclude, we have discussed a lot of concepts, lot of applications, lot of understanding that we have to understand a little bit carefully. First thing that we have understood is power has a formula V square by R. This I have already explained in the other video. I have derived it. You can use it. Second point is resistance of a heater is independent of power utilized or power drawn, and that remains constant. Taking that concept into consideration, I have equated resistance and I got the value of voltage utilized. So though it is designated to work for say 100 volts, it is able to withdraw only 25 volts. Then I have calculated further. Once after knowing the 25 volts, I have identified that this 100 volts is shared across this 10 ohms and this heater and unknown resistance parallel combination. So voltage shall be the same. Therefore, voltage total V equal to V1 plus V2. Total V is 100. V1 I have to calculate. V2 is across the heater 25. It implies V1 is 75 volts. That I have calculated here. After calculating that, I used the basic formula of Ohm's law V equal to IR, and I found that the current across this total resistance or the total current of the circuit is 75 is the total voltage, I is the total current, R is the respective resistance given for you. So I found the total current as 7.5. I found the current across the heater as 2.5 amperes. That implies current across the unknown resistance is 5 amperes. Again, using the basic Ohm's law, resistance equal to 5 ohms. So though the problem, I don't know if it is looking complicated for you, simply because of the concepts that are involved here, and I would like to get this many concepts into your understanding while you are solving this problem, which will help you to develop the overall conceptual understanding itself. Thank you for watching.